Welcome to the distance learning program presented by Innobus on JMS, which is nothing but Java Message Service. Let's see the architecture of Java Messaging Service. Any JMS application is composed of the following parts. We have JMS provider, which is nothing but it is a messaging system that implements the JMS interfaces and provides administrative and control features. JMS client, these are the programs or components written in the Java programming language that produce and consume messages. Messages are the objects that communicate information between JMS client. Administered objects. These are pre-configured JMS objects created by an administrator for the use of clients. The two kinds of administrated objects are destination and connection factories. Native clients are programs that use the messaging product's native client API instead of JMS API. An application first created before JMS API became available and subsequently modified is likely to include both JMS and native clients. These are the components which are very well composed in any of the JMS application. So let's see the architecture composing these components or the parts. So this is the basic JMS architecture where it has composed all the components or parts we just saw in last slide. We have administrative tool which has connections and destinations. There is a JMS client, JMS provider, and also JNDI namespace. To look up any service in a server, JNDI namespace is always used. It is used for binding, lookup, and also getting the logical connection between JMS client and JMS provider. That helps by binding and lookup using the concepts of JNDI namespace. This is all about Java Message Service architecture. So let's see some of the messaging domains used in Java messaging services. There are two types of messaging domains: point-to-point messaging domain and publish or subscribe messaging domain. Point-to-point messaging domain. A point-to-point product or application is built around the concept of message queues, senders, and receivers. Each message is addressed to a specific queue. Receiving clients extract these messages from the queues established to hold their messages. The queues retains all messages sent to them until the messages are consumed or until the messages expire. So let's see point-to-point messaging domain within architecture. This is how point-to-point works. In this we have the message which has got only one consumer. A sender and a receiver of a message have no timing dependency. The receiver can fetch the message whether or not it was running when the client sent a message. Therefore, the receiver acknowledges the successful processing of the message once it consumes the message. So there is no timing set for sender or receiver of the message. They can any time send and receive through queue. So this is the basic implementation of point-to-point messaging domain. Publish or subscribe messaging domain. In a publish or subscribe product or an application, client addresses messages to a topic. So publishers and subscribers are generally anonymous and may dynamically publish or subscribe to a content hierarchy. The systems take care of distributing the messages arriving from a topic multiple publishers to its multiple subscribers. Topics retain messages only as long as it takes to distribute them to current subscribers. So here there are many publishers and many subscribers involved in messaging domain. So this is the basic messaging domain of publish and subscribe. Here we have each message which can have multiple consumers. Publishers and subscribers have a timing dependence. A client that subscribes to a topic can consume only messages published after the client has created a subscription. And the subscriber must continue to be active in order for it to consume messages. So here it is all through topic. There can be many consumers. And therefore here there is a dependency of time. So let's see message driven being, which uses JMS concept. A message driven being is a message listener that can reliably consume messages from a queue or a durable subscription. The messages may be sent by any J2EE component, that is Java Enterprise Edition component, from an application client or another enterprise being or a web component or from an application or also from a system that does not use J2EE technology. A message-driven being contains an onMessage method that is called automatically when a message arrives. So like a message listener, a message-driven being class may implement helper methods invoked by onMessage method to aid in the message processing. So this message-driven being will work in this Java messaging services using J2EE component within the application server. So this is the basic message processing in a message-driven beings. So if you see here, there is a client interacting through JMS, which in turn the message-driven being where runs within the application server. The container will handle these message-driven beings. Therefore, it will pick up the messages. Also, it will pick up an instance of message-driven being and execute onMessage method. There is an onMessage method which will be used to execute on these messages. And finally, it will be invoked through onMessage. So, message-driven being will fit inside the application server, which we call as J2EE applications which run on application servers and handled by containers within the servers. So message-driven being life cycle. The life cycle of a message-driven being depends on the lifespan of the EJB server in which it is deployed. So message-driven being is of EJB being, Enterprise Java being. So therefore message-driven beings are stateless. Bean instances are typically pulled by the EJB server and retrieved by the container when a message comes available on the topic or a queue. So this message-driven beings have some characteristics. They execute upon receipt of a single client message. Let's see a life cycle of it. So there is a two-stage life cycle. That is, bean does not exist and bean method ready pool. The pools of message-driven beans are maintained within the container inside application server. And there will be a message onMessage method executed when message arrives at destination from Java message service mechanism. So if you see, this is what we were talking about all about J2EE component, and we have the Java message service consumer, which is acting as a message driven bean within the J2EE server, where the message listener of MDB, which is nothing but message driven bean, will listen within the container of EJB over the network, and after receiving the message, it will also acknowledge. So the message receiver can be through queue or topic. So if you see here, it is message oriented middleware which we have between the JMS as well as message driven bean within the application server. So whenever we have JMS message producer to produce the messages, it is sent across the network and through message oriented middleware, which we call MOM. And here either through queue or topic, the listener will listen from MDB, that is message driven bean, and then receives the messages as well as acknowledges over after receiving the message over the network. This is how typical message driven bean work within the EJB container, which is in turn running inside application server. The message driven bean also have characteristics like they invoke asynchronously, they are relatively short-lived, they also do not represent directly shared data in the database. So they are stateless. Let's see the JMS programming model. The JMS API programming model. So JMS API, it will consist of administered object, which in turn will have connection factories and destination, sessions, message producers, message consumers, messages. So before going to API programming model, let's see the components of API. We have connection. Coming from connection factory, we have message producer, session, message consumer, and destination. So all these are the components of JMS application program interface. So whenever you have any JMS application to develop, these components must be included within the development of any programming model. So it involves administered tools, which in turn has connection factory and destination. So here if you see in the diagram, the connection factory will be responsible for creating the connections. And once the connections are established, it can also get the sessions, and it can have one or more sessions generated. Within the session, we have message producer, which can create the messages, and message consumer, which receives the messages. Finally, the destination will be holding or storing all the messages coming, received, or sent. This is how the JMS API programming model works. We'll see in detail each of these components. So to beginning with, administered objects. There are two parts of JMS applications, as we have already seen. Those are nothing but just destinations and connection factories. So JMS clients access these administered objects through interfaces that are portable. So a client application can run with little or no change on more than one implementation of the JMS API. An administrator configures the administrated objects in a Java naming and directory interface. So JNDI will play a very important role in these administered objects by having lookup and binding for these objects to provide the services for the service providers. Therefore, The JNDI namespace and JMS clients then look up them using the JNDI API. Next is connection factories, which is one of the administered objects. A connection factory is the object a client uses to create a connection with the provider. So a connection factory encapsulates a set of connection configuration parameters that has been defined by an administrator. Each connection factory is an instance of either the queue connection factory or the topic connection factory interface. So these two interfaces are must to be implemented or used whenever you want to access the connection from based on your requirement. Either it can be from queue connection factory or topic connection factory. There are destinations. A destination is the object a client uses to specify the target of messages it produces, and also it is the source of messages it consumes. So as we have seen in the programming model, destination will always act as a source for messages to be produced and also to be consumed once it receives or sends using consumers and producers. In the point-to-point messaging domain, destinations are called queues. So, if you want to add your own new name for the queue, you can add in following way. If you're using a server that is J2EE, if the server is J2EE, then you have to add this command in the command prompt for adding your new queue. So as said earlier, the server also has all the setup for your Java messages. So in order to do that, you can pick up the server what you want, and based on that you have to do JMS setup on respective server. In this training, you can see the basic use of J2EE server. So using this, you can set up the queue name which you want on your name to give the new name. So here destination will be given or added with add JMS destination. These commands should be run or executed to command prompt when you are using J2EE server. So if it is publish or subscribe messaging domain, then the destination or objects are the topics. So in that case, it will be the same command, but it will be the topic name, topic underscore name, where you can provide your own topic name. So these lines are required to create or add your own destinations. Next is the connections. A connection encapsulates a virtual connection with the JMS provider. So a connection could represent an open TCP or IP socket. TCP or IP is nothing but a protocol, and between a client and provider service domain. So since it is accessing over network, you may require this transfer protocols, TCP or IP. Connection can be used to create one or more sessions. So we've also seen the architecture. Connections can create one or more sessions. The connections come in two forms, implementing either using queue connection or topic connection interface. So for example, if you want to implement the queue connection, it should be queue connection factory. Once you get the instance, after getting the connection factory instance, you can create queue connection using method through which you can get the instance of queue connections. To get the connection of queue, you need to have queue connection factory. Creating a connection factory is the first step of your JMS application, and the second step will be followed by creating the queue connection or topic connection based on the requirement. This is the example showing for creating queue connection. So sessions. A session is a single-threaded context for producing and consuming messages. You use sessions to create message producers, message consumers, and messages. A session provides a transactional context with which to group a set of send and receive into an atomic unit of work. So sessions implement either the queue session or the topic session interface. For example, if you want topic session, you have to invoke the create topic session on the topic connection. So if you remember, this is the third step. First step was connection factory, within which you got second step was creating a connection. So now is getting the session from connection. So if you go for queue, it will be again the same create queue session. For example, if you are going for topic, it will be create topic session. Next step will be the message producers. Message producer is an object created by a session and is used for sending messages to a destination, which is nothing but an object created by session. The producer will be, and it is used for sending messages to a destination. A point-to-point form of a message producer implements the queue sender interface. A publish or subscribe form implements the topic publisher interface. So if you consider, for example, queue sender interface, then it will be first get the instant of session, which we saw in earlier slide. After getting the session instance, you can create a sender, which in turn you are passing the queue and then send the message what you have to testing for. So this is how you send the message once you have got the session instance. This is for the example of queue sender. The same way for topic publisher, you can use the same to create the publisher instance and then send the message accordingly. The next will be the message consumers. Once you have sent the message, next step is to consume it. So message consumer is an object created by a session again. So as told earlier, session will create the objects for message producer, message consumer, as well as the message. And therefore, message consumer is used for receiving messages sent to a destination. A message consumer allows a JMS client to register interest in a destination with a JMS provider. So the JMS provider manages the delivery of messages from a destination to the registered consumers of the destination. So once the message consumers will allow JMS client to register, the JMS provider will then manage to deliver the messages. The point-to-point form of message consumer implements the queue receiver interface, and the publish or subscriber form implements the topic subscriber interface. So if you see, in each component there are certain interfaces which are must be implemented for your any JMS applications. So far we have seen all these components have got certain interfaces for both point-to-point messaging domain and publish or subscribe messaging domain. So here, for example, if you consider queue receiver, then in that case, it will be on the session instance, you're creating the receiver using create receiver method, which takes queue instance and finally start using the queue session to receive the message using receive method. These are the three lines. Once you get the message, you start receiving by start method and receive method. This is how the process of JMI API programming model involves. So all these are step-by-step process to be followed and to be coded by respective interfaces and then get your JMS application done by following these components and interfaces. We also do have message listeners. So listeners are very much required to know when the message has arrived. Immediately after message has arrived, it will listen to it and receives it. So let's see, a message listener is an object that acts as an asynchronous event handler for messages. So this object implements the message listener interface, which contains one method called onMessage. In onMessage method, you will define the actions to be taken when message arrives. So once you get the message, then inside the onMessage method, you can write your programming statements to take your actions upon after receiving your messages. So you register the message listener with a specific queue receiver, or it can be topic subscriber by using set message listener method. For example, if it is a topic listener, then you are just creating a new instance of topic listener. If it was a queue listener, you would have created a new instance of queue listener, and after which you also do topic subscriber dot set message listener. So using the set message listener method, which takes topic listener instance, you can set the listener for that topic subscriber. So then it happens that you have given an event which in which it will listen for a message to come to topic. Once it listens to it and receive it, it will let you give an event of message receivers. Messages. JMS application goal is to produce and to consume messages that can then be used by other software applications. So, messages are the base of JMS application programming model. So, here we are talking about producing and consuming messages. Therefore, these messages can also be used by other software applications. So, the messages have basic format that is simply and highly flexible, allowing you to create messages that match formats used by non-JMS application on heterogeneous platforms. So basically, a JMS message has three parts: header, property, body. So properties and body are optional. If you want your message only header, you have to have header in any message. Suffixing with, you can have properties on and following body. So this is the basic format for JMS message. Message consumption. So how do these messages get consumed? Let's see. Messaging products are inherently asynchronous. So in that, no fundamental timing dependency exists between the production and the consumption of a message. So messages can be consumed in two ways. It can be synchronous. Synchronous, it means a subscriber or a receiver explicitly fetches the message from the destination by calling the receive method. So the receive method can block until a message arrives or can time out if a message does not arrive within a specified time limit. This is all about synchronous messaging consumption, where the subscriber or a receiver it in itself explicitly will try to fetch the message from destination. And we know there is a receive method used for receiving the messages. The receive method can block. Blocking is a concept of synchronous where it will block and give access for messages to arrive and can time out if the message does not arrive within a specified time. Second way is asynchronous. A client can register a message listener with the consumer and A message listener is similar to an event listener. So therefore, if client register a message listener, the event listener is similar. It will act upon once it receives any messages, and it will be idle until it has not received any. So this is the concept of asynchronous. Whenever a message arrives at the destination, the JMS provider delivers the message by calling the listener's on message method. So if you see this on message message method is also used in message driven bean, so which we saw earlier. So it is all about asynchronous. Message driven bean is also an asynchronous bean which uses this on message method. So it acts as the contents of message. Also, whenever you register message listener, you call the start method which we saw earlier. So message listener will play an important part the arrival of specific messages. So in J2EE platform, a message driven bean is a special kind of message listener. So therefore, even that message listener, it has got on message method. So these are two ways. Can be a synchronous way and also an asynchronous way by message listener API through which you can consume the messages. Let's see the project setup required for JMS using WebLogic application server. We can also do the JMS programming using command prompt, and also the server can be like JEE server, which will be the latest server you can download and run through the command prompt, which we have seen through this training. But let's see the project setup where we can use the user interface facility provided by WebLogic application server and then do the setup for connection factory, queue, and many more. So the requirement for project setup for running any of the JMS application in enterprise application, we need to do the setup for JMS queue and connection factory. So let's do that. Once you have started the WebLogic server, it shows the server has been started in this command prompt. And once it is started, you have to go to this login form JSP page for localhost 7001 console. And from here, we can get into the administration console of Oracle WebLogic server. So once you are logged in with the username and password, you will get this administration console of WebLogic server. So here in domain structure, you will be able to see services within which you have messaging, and inside messaging, you can find JMS server. So here when you click on this JMS server, you will be able to add new JMS server. So for that, you have to do log and edit, and after clicking the button log and edit, new button will get enabled through which you can create new JMS server. So here you can give new JMS server as JMS server, test JMS server, and then click on next, and target you have to select admin server. So this admin server will be your WebLogic server which is running currently, and once you are done with that, click on finish. So here you have created new JMS server. So you can give any name. So here I have given test JMS server and the target is admin server. After setting the server, next thing is you have to click on JMS modules. Here you have to create new JMS module. So select new. Again, give the JMS module name as test JMS module, and this will be your module name. You can give the description file name. If necessary, you can leave these two fields blank and then go to next and select admin server and then click on next. If you want, you can check this. If not necessary, let's click on finish. So once you are done with that, you have created new JMS module. And after this, you have to select this module and then create new sub deployment. So select the tab here on the topmost sub deployment tab. You will be able to see sub deployments. Create new sub deployment. Give the sub deployment name as test sub deployment. Then click on next. Here you have to select JMS server and not the server which you are running on, because the sub deployment should run on JMS server. So this is the one which we have created recently. So select this and click on finish. So here it shows it has been created successfully. And again, after creating the sub deployment, you have to go to configuration tab, within which you can click on this button and create new connection factory. Select connection factory, click on next. Here you can give test connection factory. So you can give any name, but let's see by giving test connection factory and the JNDI name. So even JNDI name can be anything. So let's see connection factory, which should prefix with any name followed with backslash. So we will tell the reason. It should be front slash, not backslash. So it should be a front slash. The name before this can be anything, but it should always have front slash in it. You'll see the reason behind having this slash here. It is required while sending and receiving message and also getting your connection factory. So we'll see that. And once it is done, you can click on next, and here in advanced targeting button, you have to click on this button and select the sub deployment which you have created recently. So here it will be test sub deployment which we have created, within which the JMS server will be test JMS server. It will get checked automatically because the test sub deployment was on test JMS server. So we have to select this and click on finish. So once you have created the connection factory, the next is you have to create the queue. So for that, again select new and select queue. Here select next, and here you can give the queue name as test queue and then give the JNDI name as you want. So let's give as queue test queue to remember. You can give any name, but remember we need to use this JNDI name whatever we have given here. And then click next and then select the sub deployment, test sub deployment, and then it will populate with the server finish. And once you're done with this, here if you see, we have given the text connection factory, which is the connection factory we have created. The type is of connection factory and the JNDI is connection factory, that is CF. You can give any JNDI name and refer the same JNDI name which you specify here. And here the sub deployment what we had created was test sub deployment with the JMS server, test JMS server. Now if you see the queue, even queue we have created, but here it is not prefixed with slash. We have to do and prefix the slash here. In order to do that, select this and change this to JMS slash and then click on save. Go back to the JMS modules. So here you can see the details what we have created just now, connection factory and the queue. And once it is done, we have to save this changes. So here you have to click active changes in this left topmost panel. Once you have done with selecting this button, it will give all changes have been activated. Now you can use the connection factory and the queue using this JNDI name what we have specified here. So this is the setup what is required to be done for programming your JMS using WebLogic server. After the setup what we have seen now for WebLogic application server, we have got all the requirements to run our JMS application. So now let's see the demonstration on JMS using queue. The demo which we are going to see now will be on queue, the JMS using queue. So here it's a simple project created having source folder and package, within which I have two programs to send a message to the queue and receive a message from the queue. So let's see the send program. Here in this class, there are certain details needs to be given to connect to the WebLogic server. So here I've used an hash table within which we can pass the initial context factory, which is weblogic.jndi.wl initial context factory. This is the detail which should be passed as initial context factory and the provider URL. So T3 is the protocol with the local host just because it is the system, same system where WebLogic is present, therefore localhost, and the port number being 7001 for WebLogic. And for security principle, you have to give the user ID and the password. Security principle will be the user ID of your WebLogic server and credentials will be the password of your WebLogic server. These details are must to connect to your WebLogic server, and these details can be passed using property files. Now here I've used hash table. So once these details are used within the hash table instance, I'm going to pass to initial context. Initial context is the concept of Java naming directory interface which is used for JNDI lookup. And once I'll give the instance of initial context with all these details for WebLogic connection, I will be creating the lookup using context object which has been created using initial context class. And what I'm looking up here is you have to look up for connection factory. This is the entry point for your sending messages to the queue. And here if you see and recall, we had given a friend slash for connection factory JNDI name. The reason is replace friend slash with dot is the lookup does the reading on replacing the friend slash with dot. This is how you can give the JNDI name. The prefix can be anything But when you give in the WebLogic server administration console, JNDI name should be forward slash, and while coding and you're trying to look up, here you have to change the front slash with dot. Therefore, connection factory is the one which we had created earlier. The connection factory has a JNDI name. The same name should be given here. And once the connection factory, that is queue connection factory, because here we are trying to send and receive message using queue connection factory. After getting the instance of queue connection factory through this lookup of JNDI connection factory, I'll be creating queue connection. So the next step is queue connection. So once I've got the instance of queue connection, the next step is create queue session. So we have seen all these details in our JMS course training. So the same process followed. Queue connection factory, the queue connection with after getting the connection factory instance and the queue session. You have to create a queue session, and once you have created queue session, we have to look up the JNDI for queue. We have also given JNDI queue as JMS friend slash test queue, that is TQ, and here while looking up you have to replace the friend slash with dot. So this is how it will be read. So once you've given the JNDI name, the next step is you have got the queue instance, and therefore you have to create sender. So this is the queue sender, and once I get the instance of queue sender, you will create the message. So message will be the carrier for your sending. So here we are sending the message to the queue. Therefore, the message will be the carrier for your sending, within which we can get the set text. So this is the method which will send the message to the queue using the set text message from queue sender instance. So what is the message you want to send? Can be anything. You can send XML files altogether. The XML files will be read one by one. The data in and send it to queue. You can send any source of data, XML data, text data, or any data in terms of database data, any kind of data you can send as a message. So here we are sending a simple text message, hello, and once I am setting text, it will be used for sending. And if you see here, set JMS correlation ID. The reason of adding this correlation ID is because in order to get synchronized message, you have to get the order. In order to get that order, you can give the ID as 1, 2, 3 numbers. It can also be auto-generated. It will not be ordered. If it is auto-generated, it will be received in any sequence. In order to maintain the sequence, you can generate the correlation ID and pass that ID along with this message. So the same order you have sent, it will be received in the same order using this correlation ID. So we'll see this, how will this work. So next, using the queue sender, we have a method send to send the message. So here we are setting the message and here we are sending the message. So therefore, the message will be sent using this send method. And these are the steps involved in sending a message to the queue. So once you're done with, you can close everything, the session, connection factory, and also the connection. So all these can be closed once you have sent the message in cleaning up. So therefore, you can again summarize. The first thing what you have done is you're getting the initial context instance with all the credentials for your WebLogic connection and creating a connection factory instance, then connection, queue session, and finally look up for the JNDI of your queue. We have created TQ, and then create a queue sender using which we can create a text message, and also that will give you the set text method. So we can pass anything here. The content can be anything from an XML file you can read and send a message, text file, and also finally we have seen the concept of correlation ID and the use of it. Finally, you're sending a message using sender send. And here, this is the main of this class to which the send message will be invoked using this correlation ID. So here, since we are creating ID manually, it will be in an order receiving at the receiver end. If it is auto-generated, it will be order will not be sync. So this method is what will be passing it. So inside this method, we have already seen what is there. So this is that we are calling the main method of this class, which takes correlation. That is the only thing which we are passing to this method. So now let's see what is there in receive. So this was all about send program. Let's see what is there in receive Java class. So in this receive Java class, it remains the same concept. You have to connect to your server to receive and listen the message for accepting from the queue. You have to listen the queue using the connection established on server. So all the details have to be given for connection, and again the initial context creation, do the lookup for the same connection factory through which the message has been sent, and using the CF connection factory we are trying to send the message, and using the connection factory create the connection queue. It's the same process, create the session, that is create queue session, and also lookup the queue on which I have to listen for receiving the message. So here what I'm communicating is TQ, and therefore I'll do create receiver. So that is the difference. And here in receiver program I'll do receive because I need to receive, and there it was create send. So here if you see create receiver, I've got many overloaded steps. So here it takes the queue. Along with that you can pass the correlation ID. So if I'm sending 1 to 3, here I can receive the same message with order 1. So if you want to remove the order, you can just remove the correlation concept and just send the queue. The messages will be received in orderless. There will be no order. So it will be a mismatch in order. There will be no sequence in it. In order to maintain the sequence, you can have this. And once it's done, you can start listening to the message. It means it will listen to the queue. Queue will be in listen state where it can listen to the message having correlation one. You don't specify this, it will just receive the message with this queue and then connection factory. So once you have done receive, it will start receiving the messages. This is using the receiving system, and here the message what you are receiving can be monitored in the administration console of the project. Finally, you are filling up everything, and also you can verify with the messages what you get. If it is a text message, you can get the message, and respective you can perform after getting this logic what you can. And rest, there is a main method in this class, and within which we call the receive message. We have already seen what is there in receive message. The message we have already seen connection factory, connection, session, and queue receiver. So finally, this is the receiver program. So let's see how it works. So I need to send some message. So hello was the message. Run as Java application. Server is already up. Your server should be up and running. And if you see here, the message has been sent. It is telling it has sent. And what was the message? Hello. If you want this message to be seen in your administration console and verify it has been there present in your queue, you can see that. So go to the admin console of your WebLogic server. This was your queue. Click on this and go to monitoring tab. Here if you see messages current, I have sent a message. So one message has been sent. The count is 1. If you want to see the content what I have sent, Select this and click on show message, and here it is giving the ID which has been generated with correlation ID 123. Just formatting the order and the message size, so all the details of the thing. And once you get into this, here you can see the text message as being inside the queue using same concept. These are the details of the message that it has been sent. Once it is done, we can see how receive will work. So let's run the receive. So here if you see, it has read the message. It has listened to the queue and immediately it has read the message. So what was the message read? Hello. So let's see the message which has been read within the queue summary. So if you go to queue again, click on monitoring, and here if you see the message has been read, so it is showing 0. There are no messages in your queue. One message was sent and one message was read. Here you have nothing to be read. There are no items to display because I have executed the program. So now I have also read using the program. So this is the simple demonstration on queue, that is Java messaging service using queue. The same thing can be done using topic. So here we have seen the demonstration how to send and how to receive using a simple Java GMS program.